Radio-controlled cars are self-powered model cars or trucks that can be controlled from a distance using a specialized transmitter or remote. The term RC has been used to mean both remote-controlled and radio-controlled, where remote-controlled includes vehicles that are connected to their controller by a wire, but common use of RC today usually refers to vehicles controlled by a radio frequency link. This article focuses on radio-controlled vehicles only. Cars are powered by various sources. Electric models are powered by small but powerful electric motors and rechargeable nickel-cadmium, nickel metal hydride, or lithium polymer cells. There are also brushed or brushless electric motors. Most fuel-powered models use glow-plug engines, small internal combustion engines fueled by a special mixture of nitromethane, methanol, and oil. These are referred to as nitro cars. Recently, exceptionally large models have been introduced that are powered by small gasoline engines, similar to string trimmer motors, which use a mix of oil and gasoline. Electric cars are generally considered easier for the novice to work with compared to fuel-driven models, but can be equally as complex at the higher budget and skill levels. In both of these categories, both on-road and off-road vehicles are available. Off-road models, which are built with fully functional off-road suspensions, and a wide tire selection, can be used on various types of terrain. On-road cars, with a much less robust suspension, are strictly limited to smooth, paved surfaces. In the past decade, advances in on-road vehicles have made their suspension as adjustable as many full-scale race cars, today. Toy-grade RC cars. Toy-grade RC cars are typically manufactured with a focus on design coupled with reducing production costs. Whereas a hobby-grade car has separate electronic components that are individually replaceable if they fail, toy-grade cars are typically made with components harder to find as spare parts and a single electronic circuit board integrated into the design of the vehicle. Although hobby-grade enthusiasts look down on toy-grade RC cars, their maintenance is much easier than of the hobby-grade models since number of components is drastically smaller, and parts can be harvested at almost no cost from any RC toy car of the similar size. Performance is proportional to the price, but with addition of hobby-grade type of batteries, toy RC cars can get up to 1/2 the speed of comparable hobby-grade car for 1/5 of the price. Stock toy-grade cars are equipped with weaker motors and are powered by alkaline or nickel-cadmium batteries, which means their top speed is usually only 5-15 mph. Cheaper ones lack any form of a suspension, and the ones that do feature a suspension have very primitive or rudimentary designs. Steering is typically not proportional, and there is typically no proportional throttle, either, with stopped and full power usually being the only options. With all the disadvantages, toy-grade RC cars are a great intro to the hobby, especially for ages 5 to Euro 10, and a cheap platform for modifications and tuning even for older enthusiasts. Hobby-grade radio control models. In recent years, hobby-grade ready-to-run models have become readily available from major manufacturers of radio-controlled cars, attracting many hobbyists who would otherwise not have purchased a kit car. Vehicles of this type need little or no final assembly, and in most cases, the bodies are shipped painted and trimmed. Safety inspection of the product to ensure correct operation is essential, as injury to operators or bystanders from disassembling vehicles is possible. A number of cars and trucks are presently available only in ready-to-run form. The growing popularity of the RTR vehicle has prompted many manufacturers to discontinue production of kit vehicles. High-spec racing vehicles are generally still available or sold only as kits, and companies like Thunder Tiger, Lassie, HPI and Tamiya sell kit and RTR versions, with the benefits of a kit version being in upgraded parts or lower costs, respectively. Hobby-grade vehicles can cost much more, ranging from $90 to over $1,600. Electric models. Electrically powered models utilize mechanical or electronic speed control units to adjust the amount of power delivered to the electric motor. The power delivered is proportional to the amount of throttle called for by the transmitter. The more you pull the trigger, the faster it goes. The voltage is pulsed using transistors to produce varying output with smooth transitions and greater efficiency. Electronic speed controllers use solid-state components to regulate duty cycle, adjusting the power delivered to the electrical motor. In addition, most electronic speed controllers can use the electric motor as a magnetic brake, offering better control of the model than is possible with a mechanical speed control. Mechanical speed controllers use a network of resistors and switch between them by rotating a head with an electrode around a plate that has electrical contacts. Mechanical speed controllers are prone to being slow to react because they are actuated by servos, waste energy in the form of heat from the resistors, commonly become dirty and perform intermittently, and lack a dedicated braking ability. They appear only in vintage RC models, and are now essentially obsolete. Most electric cars up to recently used brushed motors, but now many people are turning to brushless motors for their higher power output and because they require much less maintenance. They are rated either in relative turns or kV. The kV number tells how many RPM the motor will turn per volt, assuming no load and maximum efficiency. However, the ability of the system to put out power is dependent on the quality of the batteries used, wires and connectors supplying power. Due to their power, brushless motors are also used in bigger monster trucks and 1/8 nitro-powered buggies that have been converted to electric. High-quality brushless systems can be much more powerful than nitro and can accomplish feats such as standing backflips when installed in a monster truck, most notably the HPI Savage Flux. Some 1/5 scale gas-to-electric conversions are in production but are uncommon due to high price. A new form of electric RC racing is mag racing. Small 1/32 scale cars and powered by rechargeable batteries and steering and speed are controlled by RC. Extra steering guidance is provided by steel wires hidden in the track surface, enabling more accurate steering than is attainable with free-running RC cars. Tracks can therefore be much narrower and smaller, making the system suitable for in-home racing. Cars can be driven back onto the track after an off, using reverse if necessary, so that track marshals are not required. Nitro 5000 powered models. Nitromethane nitro-powered models utilize a single servo for throttle and braking control. Rotation of the servo in one direction will cause the throttle on the carburetor to open, providing more air and fuel mixture to the internal combustion engine. Rotation of the servo in the other direction causes torque to be applied to a linkage and cam, which causes friction with the braking material. The brake is commonly located on the drive shaft or spur gear in some cases and applies stopping power only to the driven wheels. Some models will also use an additional servo to control a transmission box, enabling the vehicle to drive in reverse. Fuel engine sizes most often range between 0.12-0.35 cubic inches. This is due to restrictions by the main sanctioning bodies for radio-controlled racing. Many outlaw engines are manufactured larger than these, mainly intended for vehicles which will not be used in sanctioned races and therefore do not need to comply with these regulations. Engine size is related to the class of car. 1/10 scale on and off-road vehicles usually are equipped with 0.12-0.18 cubic inch engines, with 1/8 scale vehicles using 0.21-0.32 cubic inch engines. There are exceptions, with many Schumacher and Thunder Tiger team-associated RC models being good examples of unusually large engines coming as standard equipment on certain models. Fuel-powered engines allow model cars to reach moderate speeds unmodified. Maximum power is generally achieved at medium to high speeds, and a slightly slower throttle response than electrically powered vehicles is to be expected due to clutching and lack of torque. Electric motors effectively produce instantaneous torque, whereas nitro engines, like full-sized gasoline engines, take time for the engine to spool up and for the clutch to engage. Nitro-powered cars may be refueled and return to action in a few seconds, as opposed to electrics which require removal of the body shell and battery fasteners to replace a discharged battery. Nitro cars are cooled some by air, some by the oil mixed in with the fuel, and may be run continuously with no need to take breaks for cooling down, assuming they are properly tuned. Nitro-powered cars operate like full-sized fuel vehicles more than their electric counterparts do, making use of a two-stroke engine rather than an electric motor. The sound of the engine noise is a main selling point to nitro enthusiasts, even though brushless electric equivalents are generally faster. However, their exhaust contains unburned oil, which usually ends up coating the chassis. This, in turn, requires more cleaning than an electric-powered equivalent. Cleaning is usually achieved by the use of compressed air nozzles and solvents. Tuning a fuel-powered vehicle requires learning to maintain optimum performance and fuel economy, and to minimize engine wear and overheating, even in ready-to-run vehicles. Running a nitro fuel motor without tuning or tuning improperly can hurt performance in rich conditions, and cause severe damage in lean conditions. Because of their ability to be driven for longer periods of time and the use of burning fuel, mechanical wear in nitro vehicles is generally greater than in electric vehicles. In addition, the increased weight of fuel-powered vehicles generally lead to higher speed collisions, causing greater damage to the collided vehicles, and a greater degree of safety concerns needs to be taken into account. Maintenance such as cleaning of the air filter and general chassis cleaning, replacement of worn clutch parts, proper after-run lubrication and maintenance of other motor-related items such as glow plug replacement makes for a more frustrating experience for first-time RC users. In addition, nitro motors typically require rebuilding or replacement after 2 to 8 gallons of fuel run through them, due to loss of compression, which can be accelerated by poor tuning and overheating. It is also possible to seriously damage the engines by over-revving them with no load or ingestion of dirt into the carburetor. As such, nitro-powered vehicles are by nature expensive to maintain. Gasoline-powered models. Gasoline-powered vehicles, also known as four-wheelers, or gases, run on a mix of gasoline and oil. They cost much more than nitro and electric cars. They are also much bigger and therefore require much more space to run. They do not usually have as high top-end speeds but have lots of power and do not take a lot of fuel to run. Over time the cost of a gas-powered car can be less than some nitro-powered vehicles, because of the high cost of nitro fuel and buying new nitro engines to replace worn-out ones. In addition, gas-powered motors rarely if ever require tuning and have a very long lifespan. These gas-powered vehicles really pertain to the individual who is more interested in scale than imagination. These large-scale models have been popular in Europe for over a decade and have recently become very popular in the US thanks to companies like HPI Racing and FG Model Sport producing affordable high-quality models locally. Accessories and upgrades. All RC models generally require the purchase of additional accessories. For electrical vehicles, battery packs and a suitable charger are needed to power the car and are seldom included. A soldering iron and supplies are often necessary to build high-performance battery packs or install upgraded electronics with low-resistance connectors. A Li polymer battery with a hard case is most popular for RC cars, with the most common voltages being 7.4 V or 11.1 V. For nitro-powered vehicles, a glow plug heater and fuel are needed to start the engine, as well as 4 AA-size batteries, or a rechargeable 6-volt 5-cell battery pack to power then board electronics. Nitro vehicles also require a means of cranking the engine over, which can be achieved using a pull start, starter box, battery-operated roto-start, or by an electric drill. Relatively expensive model fuel, spare glow plugs, and after-run oil are also needed. Gasoline-powered vehicles require only a receiver battery pack and a means to start the engine, usually the included pull start. Hobby-grade vehicles almost always require 8 AA-size batteries to power the transmitter, though some can use rechargeable transmitter pack or simply rechargeable AAs. A large industry of aftermarket manufacturers produce upgrade or hop-up parts for hobby-grade cars. Upgrades range from mere improvements to the longevity of RC car parts, to all-out performance enhancements. A number of hobbyists create their own upgrades for sale via classifieds and online forums. Hobbyists choose to upgrade hobby-grade cars from plastic stock parts to aluminium parts to increase strength and the steering angle of the car. Ready-to-run cars can be purchased, which leave the factory in a pre-tuned condition that affords for good racing performance without prior adjustment. However, as stated earlier, those vehicles should still be inspected for loose parts prior to operation as stated in many manuals. Alternatively, vehicles can be purchased that are either in kit form or are partially assembled, which are built and tuned by the owner prior to use, but most of the time, the owner will have to buy radio gear, and sometimes even an engine when they buy a kit. Principles of operation. Radio-controlled cars use a common set of components for their control and operation. All cars require a transmitter, which has the joysticks for control, or in pistol grip form, a trigger for throttle and a wheel for turning, and a receiver which sits inside the car. The receiver changes the radio signal broadcast from the transmitter into suitable electrical control signals for the other components of the control system. Most radio systems utilize amplitude modulation for the radio signal and encode the control positions with pulse width modulation. Upgraded radio systems are available that use the more robust frequency modulation and pulse code modulation. Recently, however, 2.4 GHz frequency radios have become the standard for hobby-grade RC cars. The radio is wired up to either electronic speed controls or servo mechanisms which perform actions such as throttle control, braking, steering, and on some cars, engaging either forward or reverse gears. Electronic speed controls and servos are commanded by the receiver through pulse width modulation. Pulse duration sets either the amount of current that an electronic speed control allows to flow into the electric motor or sets the angle of the servo. On these models, the servo is attached to at least the steering mechanism. Rotation of the servo is mechanically changed into a force which steers the wheels on the model, generally through adjustable turnbuckle linkages. Servo savers are integrated into all steering linkages and some nitro throttle linkages. A servo saver is a flexible link between the servo and its linkage that protects the servo's internal gears from damage during impacts or stress. History. Early commercial products. Several early commercially viable RC cars were available by mid-1966, produced by the Italian company LGI from Reggio Emilia. Their first model, a 112 Ferrari 250 Lumina, was available in the UK in December 1966, through Importers Motor Books and Accessories, St Martin's, London, and early in 1967 through Atkinson's Model Shop in Swansea. This model was followed by LGI's 110 Ferrari P4, first shown at the Milan Toy Fair in early 1968. RC cars became possible around this time solely because of the development of proportional radio control. Previously, all radio was of the bang-bang variety, that is, steering was either left, center, or right and speed was either stop or go. This was usable for aircraft or boats but not for cars. In the mid-late 1960s, a British company, Mardave, based in Leicester, began to produce commercially viable RC cars. Their first cars were nitro or gas-powered cars sold in the local area in the early 1970s. In the early 1970s, several commercial products were created by small firms in the US. Most of these companies began as slot car companies and with the wane in popularity of that genre moved into the RC field. Among these were Associated Electrics, Thorpe, Dynamic, Taurus, Delta, and Scorpion. These early kits were 1/8 scale nitro-powered aluminum flat-pan cars powered by a .21 or smaller engine. The bodies for these cars were made of polycarbonate. The most popular engine was the K&B Veco McCoy. The primary sanctioning body for races for these cars was remotely operated autoracers. Indiana, 1973-74, Jeremy, a company based in Washington state, created their 1/12 nitro car using a Cox .049 engine. Over 54,000 were sold ready to run with radio control system, of which 25K were made by EK Product Odd Texas and the balance by Joe Mack when they bought the company from Rocket Research Corporation. Several aftermarket companies created parts for this car, including clear legs and bodies, heat sinks, and larger fuel tanks. This scale evolved into 1/12 scale electric racing when Associated Electrics created the RC-12E in 1976-77. Jeremy became Jomac and created their own electric kit called the Lightning 2000 that won the Raw National Championships in 1981 and 82 for 6-cell modified and 82 the 6-cell production classes. The Lightning 2000 was designed by Don McKay and John Congdon. By the late 1970s, interests in January 12th-scale electric racing began to grow as 1/8-scale IC racers, the sole racing category at the time, needing to race throughout the winter as an alternative to their impractical IC cars, began to race 1/12 cars, therefore a winter national series was developed. As a result, the series grew into popularity as a large number of scratch-built cars started to appear in these meetings. Again, electric RC cars were enabled by one revolutionary development, that of the nickel-cadmium rechargeable battery. Prior to the mid-70s, batteries were either heavy lead-acid or expensive throwaway dry cells. In 1976, the Japanese firm Tamiya, which was renowned for their intricately detailed plastic model kits, released a series of elegant and highly detailed, but mechanically simple electric on-road car models that were sold as suitable for radio control. Although rather expensive to purchase, the kits and radio systems sold rapidly. Tamiya soon began to produce more purpose-built remote-controlled model cars, and were the first to release off-road buggies featuring real suspension systems. It was this progression toward the off-road class that brought about much of the hobby's popularity, as it meant radio-controlled cars were no longer restricted to bitumen and smooth surfaces, but could be driven virtually anywhere. The first true Tamiya off-road vehicles were the Sand Scorcher and the Rough Rider, both released in 1979, and both based on realistic dune buggy designs. Tamiya continued to produce off-road vehicles in increasing numbers, featuring working suspensions, more powerful motors, textured off-road rubber tires and various stylized dune buggy bodies. They also produced trucks, such as the Toyota Hilux pickup, that featured realistic 3-speed gearboxes and leaf spring suspension systems. All of these models were realistic, durable, easy to assemble, capable of being modified, and simple to repair. They were so popular that they could be credited with launching a boom in radio-controlled model cars in the early to mid-1980s, and provided the basis for today's radio-controlled car market. Popular Tamiya models included the Grasshopper and the Hornet dune buggies, as well as the Blackfoot and Clodbuster monster truck models. The earliest Tamiya models, particularly the early off-roaders, are now highly sought after by vintage RC collectors and can fetch prices of up to $3,000 on internet auction sites if still in mint, unbuilt form. Acknowledging their continued popularity, several of the early kits have even been re-released by Tamiya during 2005 or Euro 2007, with a few alterations. A British firm, Schumacher Racing, was the first to develop an adjustable ball differential in 1980, which allowed nearly infinite tuning for various track conditions. At the time, the majority of on-road cars had a solid axle, while off-road cars generally had a gear-type differential. Team Associated followed suit with the introduction of the RC 101/8 scale gas on-road car, RC 12 1/12 scale on-road electric car, and RC 10 1/10 scale off-road electric racing buggy in 1984. Team Lacy followed with the introduction of the JRX2 in 1988. Modern developments in radio-controlled racing. In 1984, Associated Electrics, Incorporated of Costa Mesa, California, introduced the RC-10 off-road electric racer. This model was a departure from Associated Electric's regular line of nitromethane-powered on-road race cars. Designed as a high-grade radio-controlled car, the chassis of the RC-10 buggy was manufactured from anodized, aircraft-grade aluminum alloy. The shock absorbers were machined, oil-filled and completely tunable. They were also produced from the same aluminum alloy. Suspension control arms were manufactured from high-impact nylon, as were the 3-piece wheels. Optional metal shielded ball bearings were sometimes incorporated in RC-10 wheels and transmissions. The RC-10 transmission contained an innovative differential featuring hardened steel rings pressed against balls, which made it almost infinitely adjustable for any track condition. The RC-10 quickly became the dominant model in electric off-road racing. In 1986, Schumacher Racing Products released their Cat vehicle, widely considered the best four-wheel drive off-road buggy racer of the time. The Cat went on to win the 1987 Off-Road World Championship. This car is credited for sparking an interest in four-wheel drive electric off-road racing. Gilbert Lacy Jr., whose family ran the Ranch Pit Shop RC racetrack in Pomona, California, turned his college studies toward engineering, primarily in the field of injection-molded plastics, leading to his foundation of Team Lacy. When the JRX2, the first Team Lacy buggy, was released, it initiated a rivalry with Team Associated that continues to this day. Team Lacy went on to secure a number of achievements, which included the industry's first all-natural rubber tires, the first American-made four-wheel drive racing buggy, and an entirely new class of cars, the 1/18th scale Mini-T off-road electrics. Although Lacy and Associated seemed to dominate much of the American market, Traxxas and Kyosho were also making competitive two-wheel drive off-road racing models. Although Lacy and Associated were close rivals in the USA, Schumacher off-road models continued to be popular amongst European hobbyists. Electric and nitro cars have come a long way in terms of power. Electric cars have gone from non-rebuildable brushed motors and nickel-cadmium batteries to brushless motors and LiPo. Nitro cars have gone from small engines to huge .36-.80 engines that are used in big monster trucks. See also, International Federation of Model Auto Racing, IFMA, or in short, the international governing body for radio-controlled car racing. Also organizes its own World Championship events. References. External links, links to other RC companies and products in Wikipedia.